Hi everybody, welcome to the third lesson of this course on Internet Technologies. I'm Vardan and today we'll be studying about the layered network architecture and the OSI model. So before we dive deep into the OSI model, let's understand the idea of a layered network architecture. This is a design principle that divides the complex process of networking into separate, clearly defined layers. Each layer handles a specific role in data communication. Each layer only interacts with the one above it and below it. So each provides services to the layer above it and uses services from the layer below it. This makes networks easier to design, troubleshoot, and upgrade. This structure also ensures that different hardwares and softwares can work together smoothly, and the OSI model is the best known example of this layered approach. So, what is the OSI model? OSI stands for Open Systems Interconnection. It was developed by the ISO in 1984 as a standard framework for how different systems communicate. The OSI model breaks down the complex process of network communication into seven clear and manageable layers. This layered design ensures different systems and vendors can work together seamlessly, and it makes troubleshooting much simpler. It's important to note, however, that the OSI model is a conceptual framework. It was never directly implemented in practical networks. In fact, by the time the OSI model was published, real world protocol suites like TCP and IP had already been developed and widely adopted. And the OSI model later served as a reference guide to help document, compare, and understand how different networking protocols fit within a structured and layered communication framework. Now let's quickly visualize the OSI model through its seven layers. Starting from the top, we have the application, presentation, and session layers, which manage how the applications interact and maintain communication sessions. The transport layer ensures that the data is delivered reliably from one host to another. And these four layers, from application to transport, are collectively known as the host to host layers because they manage data communication between two devices at an end to end or host to host level. And then we move on to the lower three layers: network, data link, and physical. These are collectively called point to point layers because they handle how data physically travels through the network from one device to another by deciding path, creating frames, and sending signals through cables, switches, and routers. And now, a very important concept here is encapsulation. As data moves down the layers, each layer adds its own header containing specific information required for that layer's function, and we'll come back to this later. And first we'll look at the functions of each layer in a bit more detail, and we'll start from the top. So the application layer is the one we interact with directly. For instance, through browsers or email clients. The presentation layer acts as a translator. It converts data formats and handles encryption. And the session layer is responsible for opening, managing, and closing communication sessions. The transport layer breaks large data into segments, and it ensures they arrive correctly and controls the data flow between devices. The network layer takes care of finding the best path for the data to travel. It uses IP addresses and routing protocols to do this. And moving on, the data link layer handles error detection, and it uses MAC addresses to send data between devices that lie on the same network. And finally, the physical layer is where everything becomes electrical, optical, or radio signals. So it deals with cable switches and physical media. So this is where the data is actually physically traveling. So how does data actually move through these layers? When data is sent from an application, it passes down through each layer of the OSI model, At each step, the layer adds its own header, like a label with instructions, and this is called encapsulation. And at the receiving end, the data moves back up the OSI layers, removing headers at each step, and this is called decapsulation. An important point in this is that the transport layer doesn't worry about how the lower layers deliver data. It treats them like a black box and it simply passes down the data and trust it will reach the other side. Now let's look at the networking devices we use every day and see where they fit inside the OSI model. A hub, it works at the physical layer and it simply broadcasts data to all connected devices. A switch works at the data link layer. It uses MAC addresses to send data to the right device. And a bridge also works at layer 2 and it connects to different network segments of a LAN. And a router operates at the network layer and it uses IP addresses to find the best path for data between networks. And with that, we've come to the end of this lecture. And in next lecture, we'll get started with understanding the TCP/IP family of protocols. And thank you for learning with me, and I'll see you next time.